What we're going to work on today is learning how to solve quadratic and rational inequalities. Now that's a mouthful. Now when I'm talking about quadratics, what I'm talking about is polynomials of degree 2. And this is different from previous problems because these are inequalities, not equal. Now I'm going to solve this problem in a way that's a little bit different from other people, only because I want you to see what the solution looks like. Now, the first thing we want to do is we want to learn how to graph this quadratic. So we can think of this quadratic as y equal to this whole big thing right here. Now, the first thing we want to do is we want to find the x-intercepts. Sometimes people call it finding the zeros. The reason why is that what you do is you set y equal to 0 and then you solve for x. So let's do that. Let's find the zeros. So we'll have 0 is equal to x squared minus 4x minus 5 is equal to 0. Now, what we want to do here is we want to factor. And then we find that x is equal to 5 and x is equal to -1. Now, these are my x-intercepts. So if I was going to graph it, so right here we would have -1, and right here we would have a point on 5. Okay. Now, it's important to see that this is just a regular xy coordinate system. So the area that's above the x-axis is the has positive y values. And we can see that the area below the x-axis has negative y values. Okay. Now, all quadratics have the shape of a parabola. They either look like this or this. Now, they either open up if the coefficient in front of whatever's in front of the x squared is positive. They have they open down if the coefficient that is in front of the x squared is negative. So in this case, the a is positive, right? Whatever number is in front of the x squared, in this case, it would be a equal to 1. Since that's positive, we would draw the graph opening up. It would look roughly like this. Now, when we look at this question, right, if we sort of consider this whole quadratic to be called y, what this question is asking is, when is this graph less than or equal to 0? When is the graph in the negative y area? So if we sort of look at these regions, we can see that between -infinity and -1, the graph is in the positive y area. We can see that between -1 and 5, that the graph is in the negative y area. And we can see that bigger than 5, that the graph is in the positive y area. So, when we look back at this question, the question is, when is this graph in the negative, for what x values is this y in the negative y area? So, we can see that the graph is in the negative y area between -1 and 5. So the solution is -1 to 5, right? Between this interval and this interval, we're either at 0 or we're below the x-axis. Okay, now let's try another one. So let me give you a brand new problem, and then let's ask the question again. When is this graph above the x-axis? right? So if we name this quadratic y, we want to know when is y positive. Okay, so let's do what we did before. Let's find our zeros. And that remember that our zeros are our x-intercepts. So we will set the quadratic to 0. And then in order to factor this, I'll pull out -1 as a GCF. And then I'll factor. And then we will quickly sketch what this parabola looks like. We have our zeros at x equal 3 and x equal to 1. So remember that 1 comes before 3 on our x-axis. Okay. Now remember, anything above the x-axis is positive y. And remember, anything below the x-axis is negative y. Okay. And remember that this is just a regular xy coordinate system. Right? 0 would be over here. So if we were to roughly sketch our graph, we would look at the a value. We see that it's negative. So since it's negative, it opens down. Okay. And we can see that this graph is in the negative area between -infinity and 1. We can see that the graph is in the positive y area between 1 and 3. And we could see that the graph is in the negative y area between 3 and infinity. So if we go back to our original question, when is y greater than or equal to 0? Well, that's between 1 and 3. Now, using this graph, we can also solve other questions that are very similar to this. We could also solve when is this graph less than or equal to 0? Okay, so since this part is the same, the graph of the parabola is the same. The only thing I changed is we're looking at when is this graph less than or equal to 0, and that would be from -infinity to 1. Now we can see over here that it's in the positive y, but then it goes back into the negative y over here. We use a U for union to glue these two unconnected intervals together. Okay. Now remember, whenever we use infinity and interval notation, we always use a parentheses. Now, we can also solve two more very similar problems. If I gave you something like this, so let's say I was not using greater than 0. I was using greater than 0, not greater than or equal to 0. We would draw the same graph, and I would see that this is greater than 0 between 1 and 3. I would not use a bracket like I did over here because there's no equal. We don't want when the graph is at 0. Similarly, if I gave you this problem, and then we made it less than 0, okay, we would go from -infinity to 1, union 3 to infinity, and because we don't have an equal sign, we use parentheses. Okay. Now, let me teach you the traditional way to attack this problem. Now, in this case, we don't know how to graph this because we're no longer looking at a quadratic. X times x times x is x cubed. That's a cubic, and we haven't taught you how to graph that yet. So let's attack the problem just like we did before. Let's first find our zeros. So over here we'll get x is equal to 2. Over here we'll get x is equal to -5. And then you got to be careful with this when the number and the x is transposed. If I were to bring the x to the other side, I get x is equal to 7. So these are our zeros. X equal 2, x equal -5, 7 is equal to x. Now let's graph them on a number line. Now be sure to go from smallest to biggest. That's usually the biggest mistake people make. So -5, 2, and 7. Okay. Now, here's the idea. We know that our graph will go through these 3 points. If I'm in the negative area, if I'm in the positive area and I want to go into the negative area, the only way I can go from positive to negative is to go through 0. Since this graph is a polynomial, it's continuous, meaning that when I draw the graph, I will never lift up my pen. There'll never be a chance where I go like this, lift up my pen, and go over here. So we know that if you're going to transition from the positive y area to the negative y area, at some point you have to hit 0. So these are the transition points. So what we're going to do is we're going to put in test points, meaning that if I plug in a value like -6, which is on the left of the -5, if it's positive, then the graph is positive all the way to -infinity. If it's negative, it's negative all the way through, because the only places it can transition from negative, positive, or positive to negative is through these 3 points. So let me name this function here, f of x, just to make the notation easier. And we'll put in a test point. I'm going to put in a test point that is to the left of -5. I could have put in anything that's smaller than -5. I could have put -7, -10, -100, and -1,000,000. Any of them work. So when I plug in f of -6 into this expression, I'm not really interested in what the value is. I'm really only interested in what the sign is, what the sign of the number is. So this right here is -8. This right here is -1. This right here is 13. But I'm not even going to bother to actually multiply the numbers. I'm just going to look at the signs. I have a negative number times a negative number times a positive number. Negative times negative is positive. Positive times positive is positive. So I know that my graph is positive to the left of -5. Now, my graph could have bounced off of that point, or it could have gone through 5 into the negative territory. So I now need to test a point that's between -5 and 2. Let's pick 0. So again, we'll plug in 0 into here. We pick 0 because it's in between -5 and 2. And we'll get 0 minus 2, 0 plus 5, and 7 minus 0. Again, we're only interested in the sign of the answer. So that'll be negative, that'll be plus, and that'll be plus. So negative times plus is negative. So then that negative times plus is equal to negative. Now let's pick a test point between 2 and 7. So this goes 3 minus 2, 3 plus 5, 7 minus 3. And this number is positive, this number is positive, and then this number is positive. Positive times positive times positive is positive. Oh, sorry, this is negative. So up over here it's positive. Okay. Now let's do one last test point. Let's pick a number that's bigger than 7. We can pick 8, 9, 10, 11, a million. Let's just pick 8. So we'll get 8 minus 2, 8 plus 5, 7 minus 8, and we'll get plus, plus, times, minus. Plus times plus is plus, and then that plus times minus is minus. So roughly I know that my graph will be in the positive y area if it's smaller than negative 5. Then the next interval will transition to the negative area, and then it'll transition to the positive area, and then it'll just stay negative. Why? Because I know that I never ever hit the x-axis again. Okay. Now, let's solve this problem. I want to know when y is greater than 0. Right? So I want to know when this graph here is in the positive y area. So that will be, so let's put ends on our interval. That'll be from negative infinity to negative 5. And then because there's no equal sign, we'll put a parenthesis. And then we'll connect it to this part over here, 2, 7. Again, parentheses, because there's no equal sign here. Okay. Now let's work on rational inequalities. Now, what rational means is fraction. So what we have here is a rational expression because it's a fraction. And I want to know when this is equal to less than or equal to 0. Now, rational is a little different because we have the possibility of getting undefined when we have a rational. Meaning that if I were, for example, to ask you what is 0 divided by 3 equal to, well, that's equal to 0. But if I was to ask you what is 3 divided by 0, well, that would be undefined. Okay. So if the top part is equal to 0, the numerator is equal to 0, that gives me a 0. And if the bottom is equal to 0, so if the denominator is equal to 0, that gives me an undefined. So the first thing I want to do is I want to find our zeros. Okay, so we have a 0 at x equal 5, and then I want to find our undefineds. So that's when the denominator is equal to 0. So the way I'm going to draw it on the graph is that at negative 2, we have undefined. Meaning that my graph will never touch that point. It can go over it, but it'll never touch this point. Basically, when we're drawing our graph, we're lifting up our pen and then either going to the other side or staying on the same side. Okay. Now, at 5, we're saying that our graph touches that point. Okay. So, let's sort of go back to our previous example. Rational equations are not continuous. So if I were to go from here to here, I have two options. If I were to go from change signs from plus to minus y, I have to either hit the x-axis, right, hit the 0, or I could lift up my pen. So I could have a discontinuity, and that's what the undefined is. Now we're going to solve this problem exactly the way we did by plotting test points. These are the only places where there's potential for my graph to go from positive to negative or negative to positive. Okay, so let's put a test point down. Let's look at a point smaller than -2. Okay, so if I plug in -3 into here, I get a negative number over a negative number, and then that gives me a positive number. Okay. Now, that means that my graph over here was in the positive y territory. Now let's pick a point between -2 and 5. So I'll pick 0. So I have 0 minus 5 over 0 plus 2 is equal to a negative number divided by a positive number is equal to a negative number. So then it's negative here. And then let's pick a point bigger than 5. So I'll go 6 minus 5 over 6 plus 2 gives me a positive number over a positive number, which is a positive number. So then this is positive. So my graph is first in the positive y area, and then you'll do some stuff in the negative y area, and then you'll go into the positive y area. My graph has some characteristic like that. Now, when we're looking for our solution, we have to be very careful. This is asking, when is this negative, right? When is y less than equal to 0? Well, it's negative in the middle over here. Now, this point does not exist, which is why if we have a undefined, we always use a paren. Whether that is equal or not, if we're referring to an undefined point, we always use a paren because that point does not exist on our graph, so we can't ever touch it. Now, because this is a 0 and we're looking for less than or equal to 0, this one will be a bracket. So this is the only thing you have to be careful about when you're working with rational inequalities. Okay. Now, until now, the right side of the equation has always been 0. And that's the thing that we have to be careful about. Before we start doing test points and finding zeros, we have to make sure that our rational expression or our quadratic is equal to 0. Okay, so this must be 0. Okay. So what I need to do before we start is make that 0. So I'm going to subtract 1 from each side. See, I'm sorry, that's 0 now. I just brought that 1 to over here. Now I need to then add these two together. So I need a common denominator. So that's a minus. And you can see that this is equal to 1. Now be careful, even though there's no parentheses there, there's a parentheses there. So you will end up distributing that negative on top. So this will give us x plus 5, and then if we distribute that negative, minus x minus 2 over x plus 2, and these are all greater than or equal to 0. And then that gives me 3 over x plus 2 is greater than or equal to 0. Okay, now let's be careful. When the top is equal to 0, that gives me my zeros. And when the bottom is equal to 0, that gives me my undefined. So first let's find the zeros. So we have 3 is equal to 0. Now that's a nonsense equation. It doesn't make any sense. 3 will never be equal to 0. Since we have no variable there, we have no zeros. So let's find our undefineds. Okay, so we have x plus 2 is equal to 0, x is equal to minus 2. So if we were to graph that, we would end up with negative 2 like that. So let's do our test points. F of negative 3, right? We're going to pick a point to the left of negative 2 when I plug that in here. Now be really careful that f of x is equal to this. When we're playing our game, this side has to be equal to 0, so we can't use this expression. We have to use this expression down here. So this is going to be our f of x, the one that's transformed when it has 0 on the right side. Okay. So when I plug in negative 3, I get 3 over minus 3 plus 2, which is a positive number, divided by a negative number, which gives me a negative number. And then let's pick a point to the right of negative 2. 3 over 5 plus 2 gives me a positive number divided by a positive number. This is equal to a positive number. So this is negative. This is positive. So my graph looks something like this, right? Spend some time in the negative y area, and then it spends some time in the positive y area, and it never touches that point. So when we go back to here, we want to know when the y is, when the graph is in the positive y territory. So then my solution is, see, it's positive y over here. So my solution is negative 2 to infinity, right? And it's negative 2 because that's my undefined.